Hi everyone, Miss Tui here. Ozobot can be programmed to travel at different speeds, but it wants to know exactly how fast it can move. Today, you will use the scientific method to test and investigate Ozobot's speed using different color codes. Then you will use math to calculate the exact speed that Ozobot travels. For today's lesson, you will need an Ozobot, fully charged and calibrated, color code markers, a pencil, all 3 pages of the What's the Speed activity sheets, and a timer. In today's lesson, you will use color codes to program your bot to travel at different speeds, make a hypothesis about the speed of each color code, complete multiple tests with each color code to determine how long it takes your bot to travel the same distance, and use data to round and divide to find the exact speed. Speed is the distance an object moves in a given amount of time. You can also think of speed as a measure of how fast something is traveling. When you think of speed, you may think of miles per hour, which is used to measure the speed of bicycles, cars, and planes. To determine the speed of an object, you divide the distance the object traveled by the time. You will use the scientific method to learn about the speed of your bot. The scientific method is a process scientists use to study, investigate, and solve problems. Let's get this investigation started. Look at sheet number 1. The first step in the scientific method is to ask a question. This step tells you to identify the focus of your investigation, which is usually stated as a question or a problem. The question for your investigation has been given to you. The goal of your investigation is to find an answer to this question. The question you are going to answer after your investigation is complete is, what's the speed of Ozobot when programmed with each color code? Now that you know the focus for your investigation, let's move on to step 2 in the scientific method. Make a hypothesis. A hypothesis is made before the investigation begins with little evidence. You can think of making a hypothesis like making a prediction. In the column next to make a hypothesis, you will see 5 different speed color codes. These are the color codes you are going to test and determine the exact speed programmed. Make a hypothesis about the increase in speed by numbering them 1 through 5. The slowest color code has already been identified for you, marked with the number 1, or red, black, red. Can you number the other color codes using numbers 2 through 5 to predict the order from slowest to fastest? In order to complete your investigation, you will use a testing map. When you look at the testing map, you will notice there are 5 starts and 5 missing color codes. Each line is 6 inches from the color code to the end of the box. Since you are measuring speed, it is important the distance is the same for all tests. You will need to use your color code markers to complete the testing map. I'm going to use the color code shown on sheet 1 to put a different speed code on each line. The first will have red, black, red. The second will have blue, green, blue. The third line will have blue, black, blue. The fourth line will have green, black, green. The fifth line will have blue, green, red. At the end of each line, I will color a red box. Can you use your color code markers to put a different speed code on each line and color the boxes at the end red? You are ready for steps 3 and 4 of the scientific method to test and record your results. Now that your testing map is complete, you will use a timer to investigate the speed of your bot. You can use a timer on a cell phone, a watch, or even a kitchen timer. You will place your bot on start of the first line and use the LED light indicators on your bot to start and stop your timer. I will put my bot on the first start. When I see the color sequence red, black, red process on my bot, I will start the timer. When I see the LED light change to red, I will stop my timer. My bot took 6.9 seconds to get to the end of the line. I will record this data or information on the data chart in the first row with the color code red, black, red, and in the third column labeled test times. Next, I will put my bot back on the same start to complete 2 more timed tests. After I've tested the first speed 3 times and recorded each time, I will move on to the next color code, blue, green, blue. When I see the color sequence blue, green, blue process on my bot, I will start the timer. When I see the LED change to red, I will stop the timer. My bot took 2.33 seconds to get to the end of the line. Since the speed of my bot increased, I'm going to run the bot back on red, black, red line to program my bot to always start at the slowest speed. This will make it easier to see when to start the timer. Now I will put my bot back on the start of the second time test to complete the series of 3 trials. Repeat this process with the remaining color codes to record your data. If you do not have your own timer, use the timer in the next chapter of the video. Can you time your bot as it follows the color codes on each line and record the times? Remember to start the timer when you see the color sequence light up on your bot and stop the timer when the light turns red. You will test each color code 3 times. If you need a way to time your bot to complete the test, you can use this timer. You will want to pause the video so that the timer starts at 0. When your bot processes the color code, you can press play on the video and the timer will begin to count up. When your bot turns red, pause the video again and record the time. Repeat these steps by playing the chapter again. After your tests are complete, it's time to look at the data or results. You will look at all 3 times for your color code test to choose the median or middle value. Then you will round the number to the nearest whole number. For example, when I tested my bot with red, black, red, it traveled for 6.9 seconds, 6.74 seconds, and 6.33 seconds. The number in the middle is 6.74. If I round this number to the nearest whole number, I get 7. I will write this number in the column labeled time chosen. Now I will find the median or middle value for the other color code tests and round the times to the nearest whole number. Can you find the median number for each color code test and round it to the nearest whole number? Write the rounded time in the column time chosen. Time to use your data to answer the focus question. What's the speed of Ozobot when programmed with each color code? You will notice on the data chart the distance of 6 inches is already filled in for you. Ozobot traveled 6 inches from the color code to the end of the line for each test. Now that you have a time for each color code test, you can find the speed of each color code. To find the speed of an object, you divide the distance it traveled by the time it took. On my data chart, Ozobot traveled 7 seconds when it was programmed by the red, black, red speed code. If I divide distance 6 by time 7, I get 0.86. This tells me Ozobot travels 0.86 inches per second when programmed with red, black, red speed code. I'm going to find the speed of the other color codes. Can you find the speed of each color code by dividing the distance by time? Finally, on to the last step of the scientific method. Draw a conclusion. Reflect on the hypothesis you made at the beginning of the activity. Was your hypothesis close to the results? Which color code did you think would be the fastest? Which color code was actually the fastest? Can you draw a conclusion based on your data by writing the color codes in order from slowest to fastest on sheet 1? Remember to check your work. Your testing map should have all 5 speed color codes. Sheet 1 should have your hypothesis written and your conclusion written. Your data chart should have 3 times recorded for each color code test, a time written rounded to the whole number for each color code, and a speed found for each color code. Come back again soon for our next lesson.